So this problem is testing on test for continuity. So we want to examine the continuity of the function f of z at z equals to 2, where the function f of z is given by z squared minus 4 over z minus 2, whenever z is not equal to 2, and value of the function at 2 is given by 2. So there are two things for us to test. One, to find the limit of the function as z approaches 2, and then determine whether the limit is the same as the value of the function at z equals to 2. So solution. So we test whether one, limit as z approaches 2 of f of z exists, and then number 2, limit as z approaches 2 of f of z equals to the value of the function at 2, which is equals to 2. So these are the two conditions to test. If we are lucky to find all of them being satisfied, then we say the function is continuous at the point z equals to 2. So let's start by the first one. Limit as z approaches 2 of the function f of z will be limit as z approaches 2. Now we use this first formula here. So z squared minus 4 over z minus 2. You realize that this is the difference of two squares. So this limit as z approaches 2, z minus 2, z plus 2, you divide by z minus 2. So this and this cancels out, and we'll have limit as z approaches 2 of z plus 2. Direct substitution gives us 2 plus 2, which is 4. So indeed, the first property is satisfied, that limit as z approaches 2 of f of z has a value of 4. Now, f of 2 is already given as 2, but since limit as z approaches 2 of f of z is not equals to f of 2, because this value, i.e., is not the same as 2, then the function f of z is not continuous at z equals to 2. But note that this is an example. Note this discontinuity can be eliminated by redefining the value of the function f of z at z equals to 2. i.e., if we define the function as f of z equals z squared minus 4 over z minus 2 when z is not equals to 2, and we say 4 when z equals to 2, then f of z will be continuous at z equals to 2. So these are an example on discontinuity called removable discontinuity. So the discontinuity in this case is called removable discontinuity because you can remove the discontinuity by redefining the function. It's called removable discontinuity. So that's how we are supposed to solve that problem. Thank you.